Hello, James Flaten here with the Minnesota Space Grant. I'd like to talk through the innards of a high power rocket. So here's a high power rocket. See the nose cone up here, there's body tube, fins down here. This happens to be a dual deploy rocket, which means it has two parachutes. So while in flight, it separates here. There's a coupler tube inside the center of the rocket, and it separates below the coupler tube. There's the fin section. And then as it comes down under a small drogue parachute, it will eventually sense that it's getting close to the ground, and then it will separate here. The parachute, the bigger parachute up here, blowing off the nose cone and pulling out a bigger parachute. Unfortunately, it's kind of hard to tell what's going on inside of a rocket like this. And so what I'd like to do is talk through a split rocket. So what I have here is kind of a similar size rocket, except it's been cut. It's been sawed in half, right down the middle. And so this particular split rocket is set up as single deploy, single parachute, one side. And then here's the other side of that same rocket. Dual deploy. You can see two parachutes, one here and one here. So although it's going to be a little hard to see the entire rocket at a time, what I want to do is just talk through both of these splits, pointing out some of the parts as we go. On the other hand, those particular split rockets are bolted together so they don't fall apart during transportation. So they won't, in fact, slide apart the way they should, the way I showed you with the real rocket just now. So let me switch over to a different camera. And let's talk through first the single deploy rocket. Okay, so here's the single deploy rocket. Basically, there's the base of the rocket. You can see the fins. Okay, I can see the single parachute here. I can see the nose cone up here. And so, well, let me start with the nose cone. So basically, here's the nose cone. The nose cone fits inside of the rocket. So basically, there's an overlap. That's the shoulder. And then the airframe in this particular rocket has two sections, which is broken right here. There's a separation point right there. Okay. So this coupler tube is inside the rocket so as to keep the upper section and the lower section aligned with each other. And in actuality, during the flight, the rocket would separate here with the entire upper half, including the nose cone and the upper section, and the coupler tube going in one direction, and the entire lower half going in the other direction, and the parachute coming out in between. In this case, I have a single parachute. It's quite exposed. And the reason it's exposed is because it's protected by a sliding piston. So this is a little unusual. Let me set the parachute outside of the rocket. And you can see this piston, which is a piece of coupler tubing, has a bulk plate here. And so the idea is when there's an explosion from the upper end of the motor, at this point, it pressurizes the bottom of the rocket, pushes the piston forward, and then the piston pushes the nose cone off and the parachute up here. But the piston actually serves to protect the parachute, so I don't need to wrap the parachute up in any flame protecting cloth or anything like that. And then here's the very base of the rocket. So what I can see is, I can see a motor mount tube that the motor would stick in here. I can see centering rings holding the motor mount tube centered, a rear centering ring, an upper centering ring. There are fins. And one nice thing about this view is I can see the fins on the outside of the rocket, and I can also see the fins extending to the inside of the rocket with epoxy outside and epoxy inside. Okay, so that's the part that is important to do, but is not visible once the rocket is fully assembled if you don't have it split in half. Oh, one more thing is over here I see a rail button. And this particular rail button is a screw-in rail button. So there's a piece of wood in the inside for it to screw into. Okay, so that's the single deploy rocket. Now let me shift over to the dual deploy rocket. Same deal, starting at the top. There's the nose cone. Oh, one more thing about the single deploy rocket, sorry, is that there happens to be, hanging right here, an altimeter tube. This is just a data logger. So this is something that could, for instance, keep track of the performance of this rocket. It's just dangling from the bottom of the nose cone. For the dual deploy rocket, the nose cone is a little bit different. In this particular case, there is a bolt plate added to the nose cone so I can add an eye bolt and really hold on tightly to the nose cone. And then in this upper section, this is the tightest part of the rocket right here. And this upper section is actually the largest parachute. And the largest parachute is inside of a flame protecting cloth and has recovery harness that goes to the nose cone and recovery harness that goes to the top of the coupler section. Now this is different also. The coupler section has bolt plates on both ends with an eye bolt here and an eye bolt here. And then since those are a bolt plate, that means that that's reserved space. And inside of here is where I can build an avionics bay. So this avionics bay happens to have a Raven 4. So this happens to be an altimeter that is able to fire ejection charges. It has a place for a battery. One thing that's missing right now is the switch to turn it on, which would have to be on the outside of the rocket. And then the Raven 4 is attached to wires that are up here on the upper bolt plate and a place for an explosive charge. It could go right in here. That would be an explosive charge to fire to get the main out. So when this charge goes off late in the flight, it blows the nose cone off. It brings out the parachute that's in that section. And then down here at the bottom end, okay, so I have wires that come to here. There's a terminal block, so I can make and break those wires without having to open it up. And then a place for an explosive charge down there. And an eye bolt. So this forged eye bolt is attached to recovery harness, which goes down to, hard to see because it's black. Okay, very small parachute, my drogue parachute, inside of flame protecting cloth. And then the recovery harness continues down to the base. One comment about this one, and that is, this one might possibly experience explosions coming from the motor and or explosions coming from the avionics bay. And so it's really important to wrap this parachute up carefully so it can deal with explosions coming from either end. In the case of the other parachute, the explosions only come from below the parachute, and so you can wrap it a little bit less rigorously. You should, of course, wrap it carefully. And then the fins and how the fins are attached is similar with external fillets, internal fillets, motor mount tube here. There used to be a cut-in-half motor, it's gone. Centering ring to hold the motor mount tube centered, a rear centering ring, rail button, and a little piece of wood on the inside. And then there should be, let's see if I can find it. Oh yeah, here it is. Another rail button, which would be at the center of mass, and another piece of wood on the inside. You have to be careful. This wouldn't work in the piston rocket, and the reason is that would interfere with the piston being able to slide properly. So you have to be careful what kind of attachment you have, especially if you have a piston or a parachute that needs to move around. In this case, I'm not too worried, but there is a bit of a sharp point there. It's possible that I could grind that down or cover that with epoxy to try and make sure that nothing snags on that. For instance, if a parachute needs to go past that point. This particular rocket happens to have, for motor retention, a screw-on motor retainer. So the centering ring, the motor mount tube has to stick out far enough for that screw-on motor retainer to work. On the other hand, another kind of motor retention that I tend to use is screws and T-nuts. Those would go right through here and right through here. And those are not on this particular split model. So there we have it. Let's take a quick look at this original rocket one more time. So remember, the nose cone has a shoulder to make sure it stays aligned with the upper section of the airframe. Okay. The upper section of the airframe is aligned with the lower section of the airframe by a coupler tube on the inside. And in this case, since it's dual deploy, I want to have electronics. So there will be a bulk plate here, a bulk plate here to keep the electronics away from the explosions. The first explosion down here separates the rocket below the collar, and the upper half of the rocket comes down and the lower half of the rocket comes down, tied together with a drogue in between. And then as you get close to the ground, you get a second bigger parachute to come out by an explosion up here. And that's what lands you safely. And then in this particular case, there's an externally mounted camera pod. And then there are the fins. And the fins, just like in the split rocket, go inside and reach all the way into the motor mount tube. I can see the motor mount tube here. I just can't see all of the gluing that went on inside. And then here's the rear centering ring. And here's one of two. There should be a second one right here. But anyway, so one of two T-nuts and bolts that would be used for this kind of motor retention.